Alright, this is video 5, so we're going to start with number 18. And so they give you a picture, guys, of a graph, right? And so they want you to find all the stuff about the graph. And so what I'm going to do, this one's kind of tricky. What I'm going to do is I'm going to just draw like a little, ooh, sorry, keep hitting my lamp switch off. I'm going to draw just a little quick sketch. So they tell you that one of the points is 3, 2, and then another point on the graph is 1, negative 2. Okay? So I'm going to write that. Okay, so the generic equation, guys, for a absolute value, if you guys remember from a while ago, is y equals a absolute value x minus h plus k. And so they give us 2 points right here. This 3, 2, that's your vertex. That's your h and that's your k. And then this is just a random point on your absolute value graph. I'm going to call that x and y. Well, if you guys look at the equation right here for number 18 that I wrote, there's how many letters? 1, 2, 3, 4, 5, or variables, right? There's 5 variables, and we know 4 of them, x, y, h, and k. H and k is always your vertex, and then x and y can be any point on the graph. So what I'm going to do is just plug in what I know. So your x is 1, your h is 2, and your k is, let's see, y is negative 2. I don't know what a is. My x is 1. My h is 3. Sorry, not 2. 3. There we go. And then my k is 2. So now I can just solve for a. So I'm going to simplify my absolute value. 1 minus 3 is negative 2. And then now it's like the evaluate problems. The absolute value of negative 2 is 2. I'm going to rewrite this as 2a because it's better math manners. So this becomes a 2. Absolute value of that is 2, and then you have 2a. So I'm going to go ahead and subtract 2. So you get negative 4 equals 2a. Divide by 2. So a equals negative 2. Alright, so when you're writing an equation, you always have y and x stay. So I'm going to fill in everything else. Your a is negative 2. Your x stays. Minus your h, which was 3. And then your k was positive 2. That is the first thing they ask you. That is your equation. So then let's talk about the domain of our graph. Our domain of our graph, if you look at your picture, guys, left to right, the domain of our graph is always going to be for an absolute value. Does not matter what you do to it with the transformation. It is always going to be negative infinity to positive infinity. So in interval notation, it'll be negative infinity to positive infinity, just like that. If you want to write it in set notation, set builder, it's going to be your curly braces. You're going to do the all real number sign, just like that. So that is the second thing they are asking us in our graph. Now the next thing they ask is the range. So our range in this case in interval notation, remember that is always bottom to top. So if I read this graph bottom to top, it's going to be from negative infinity, right, parentheses, all the way to my highest y value point. What's my highest y value? 2. And that is included, right? That is a closed dot, so that's going to be a bracket. So it looks just like this. Let me zoom out so y'all can see a little bit better. So for set notation, right, set notation, same thing. I'm going to now do a y for range. Draw your line. And then your y's are going to be greater than or less than. In this case, it's going to be less than, right, because they're negative. So y is less than or equal to 2. That is your range in both notations. Okay, the next thing they ask is what is the vertex? Remember, the vertex is just your point. It's where it flips, goes from negative to positive. So this is going to be 3, 2. That's the coordinate. And now we have to list our transformations. So if I look at my equation, that's where you get your transformations. This right here, guys, is kind of tricky. This is 2 transformations. Negative 2, the negative does something to the graph, and the 2 does something to the graph. Because remember, your parent function is just y equals absolute value of x. Everything else you see, so I have 1 transformation here, 2, 3, and 4. So this negative on the outside, what that's going to do is that's going to flip over the x-axis, or you can call it a vertical flip. That's the same thing, which makes sense, right? It was pointing up, and now it's pointing down. So that's the negative. The 2 is in vertical land, so that's going to be a vertical stretch, right, by what it says. It's multiplying, so it's vertical stretch by the number, by 2. All right, inside the absolute value, this is horizontal land. This is where everything gets a little funky and backwards. This is your horizontal shift, so that tells you if you go right or left. You do the opposite. So do you see how it says negative 3? It looks like it goes left 3, but it's actually going to be the opposite. It's going to go right 3. And then this last one, it's in vertical land, it's outside the absolute value. Do what it says. That's going to tell you whether it's up or down. This is going to be up 2. That is your transformations for number 18. Alright, so let's look at 20, which one's also kind of tricky on this review. You have a g function, right? They just different names. Your function, first one is g. It's 2 times x plus 4 of the absolute value of that, minus 3. And then h of x equals 2x minus 1 minus 1. And they're asking, how did it go from g to h? What changed, right? So if you look here, let me draw, I love drawing little sketches. If I draw a sketch of g, don't worry about the stretch, because you see how the stretch is the same. So that doesn't matter. Let's focus on the horizontal and vertical shifts. So x plus 4 means it's going to go left 4, right? Because it's in horizontal land. And then minus 3, it's going to go down 3. So this is your graph of g of x right here. That dot. That's just the vertex, right? It's really like a V, but I just care what's happening with the vertex. This one means it's going to go right 1. So I'm going to go right 1 and then down 1. Right 1, down 1. So this is the graph right here. It's also a V. This is h of x. So they want to know, how did this guy change from this guy? Well, if this guy, from here to here, this goes up 1. So in order to go from here to here, you're going to go up, what is that, 2? You're going to go up 2 and then over 1, 2, 2, 3, 4, 5. So you're going to go, in order for g to go match up with h, you're going to go up 2, right? And then you're going to go over 1, 2, 3, 4, 5. So left 5. That's how you get this dot to match with this dot. It's like the slope. You're comparing the slope. You're going to go up 2 and over 5. Okay, that's it, guys. That's it for this section.